Right, here we are. Further investigations with the VOX T-60. As I mentioned earlier, I did uncouple the AC supply from the transformer to the rectification circuit, and I had about 53 volts, which is perfectly okay. I then reconnected it, and well, before I reconnected, I noticed that this particular one resistor here was burnt up, and that was the one that was smoking like anything when I ran up on the variac. So I put brand new ones in here, 5-watt ones in there, and I put a lot of other new ones as well. These are 5-watt ones, and I checked the diodes and they were absolutely fine. Reconnected everything, and I had about 21 volts here, which is perfectly what I expected to see. And yeah, that was fine, but I thought, well, I'll check everything individually as I'm in for the long haul on this. There's I'll just get my torch. There's 3 OC44s, 2 there, and this was originally an OC44. Somebody's cut it off and replaced it. You can see where it's been joined. But yeah, and so I disconnected them from the boards and I tested each one on my transistor tester, and they're absolutely fine, perfect. Which surprised me, because I expected to find probably one at least gone. You know, because PMP germanium transistors don't have a particularly good reputation. And there's another one here. All tested, all good. So I thought, right, I'll do the best thing to do here is just go through this lot. So every electrolytic capacitor in here has been replaced with brand new ones. Got to bear in mind these are all 60 years old. And I found a couple of wires off actually. One was to go, which went to the vibrato unit. That was off, so I thought, oh, that's probably why that ain't going to work, because the wire's off. But that wasn't the case. But I reconnected that, and there was another wire off down here somewhere. And apart from that wire that was off here, I showed earlier in the video, somebody had been in here. Yeah, and so I replaced all them, tested everything. I originally had these monster capacitors like you had back in the day. That's what they were back in the day. Look at these, and these are hard to get these days, and they can be expensive as well. So I gutted all them, fitted new cradles, and I fitted modern capacitors, just a fraction of the size, do exactly the same job, and they're cheap to buy and easy to replace should somebody need to do it in the future. Yeah, I swapped all the owner of this amp. When I told him that some of the transistors, the OC35s, were good, he said, "Well, how about, what do you think about replacing them with some new ones I've given?" Because he gave me some brand new ones. I said, "Well, it's up to you. You can if you want." I said, "Okay, I'll do it." So I replaced them because that's what he wanted. Although the old ones were absolutely fine, but there's got plenty of spares now anyway. So yeah, so that's all replaced. The only thing, and all these ones up here, that was replaced as well. I cleaned all the jack sockets, of course. There was tons and tons of debris everywhere in this amp. I mean, you can see I cleaned some of it. It was rusty, grimy dusts and everywhere. Anyway, so the only one I haven't yet changed, but I've got on order, is this television radio suppression cap here, which I think this is what it is, because it's hooked straight up to the 240 mains, and so that's rated at 1000 volts and 100 NF. I've got that on order, some new old stock. That's the only one I haven't changed yet. That's coming. I've had this up and running now. It's not a bad little amp actually, not bad at all, especially considering a solid state. Because a lot of solid state ones of this period are pretty awful sound, and I know, I had them. Going on to the vibrato unit. The vibrato unit is in the back of the cabinet, the combo cabinet, mounted in the wall on its own. It's separate from the main area, just connected by wires, obviously. And this is what it looks like inside. There's 3 OC44s in there. So my first port of call was to check them, so I uncoupled them and checked each one on the tester, and guess what, they're all absolutely fine. So with these sort of vibrato units, and the same with tremolos, the modulation units, they're very susceptible to the values of the components shifting. As with age, typically the values start to climb up, and just a small change in one of the components can cause it to stop working or almost stop working. So there's no schematic for this that I could find. All I have is the main circuit here. And if you look closer, because I've got some earlier ones here, look on this one it says connections for vibrato unit, but there's no schematic for it. So you know, I'm flying by my seat on the pants on repairing this because it wasn't working at all. I repaired the main connection here, which was broken, I said a little while ago. No such luck, it didn't make any difference. Now I checked the power, we've got about 12.5 volts DC coming in here. So I thought, right, I'm going to have to start checking the likely culprits in here. We're going to be capacitors and resistors that are drifted. Somebody slung an array of capacitors underneath here. They were 247 UF caps, axial caps, in series to each other, so it's done about 22 UF. And I thought, well, I'm going to start with, so I uncoupled them and I tried a selection of capacitors varying from 100 NF UF up to 1000, and I found every time I raised the value of the capacitor, I started to get a signal, then a stronger signal, then a better signal, and I ended up putting that there is my one. I put 1000 UF radial cap underneath. That's slung on the underside because there's not much room on the top. As you can see from the posts there, it's only about ½ inch, 3/4 inch clearance because there's a case that goes over this, a metal case. And so I slung it underneath, and I got not a bad signal at all. You know, I got vibrato, speed and depth, but not as good as I would like. So I looked a bit further, and there's a cap up there. I forgot what that is. I think it was 100. I swapped that out for new, and it got a little bit better. And then I thought, well, I don't know. This depth control here, if you turned up to maximum, that's what started to sound good. You know, that felt like it could go a bit further. So, in fact, and there was a resistor there, like you can see. I'll point to it if I can see it. Where is it? There it is. That was I can't. Was it 100k, I think. And I reduced that to get to 68, and when I did that, this depth control came alive big time. So you've got plenty of depth now, from right off no depth up to quite a bouncy depth indeed. So yeah, I saw there's a couple of other things, like there was a lot of burn marks on here where people got a bit happy with their soldering on and damaged things, and so I repaired all that sort of stuff, and I found another wire broken on here as well. So now I'm happy with that. It's working just about as best that's going to get, and yeah, so that is that. I'm really at the stage now where it's ready to go back into the combo cabinet, hook everything up and give it a run. Obviously I've bench run it for about an hour or two last night here on the table, hooked up to my well, I hooked up to the actual original cabinet by a long lead. It's just sitting here, and yeah, so that's pretty good. I'm quite pleased with this because it's been a lot of work for me to do. There have been a lot of issues with things broken or not been mucked about with, you know. But I'm very pleased with the results. It's good, and there's no real reason why this couldn't be kept going for quite a few years, as long as transformer hangs in there, but hopefully that'll be okay. And of course you've got the secondary transformer on here. Unusual so much on solid state, but early versions of solid state amplifiers sometimes did have a transformer, and this is what this is. It's not a choke or anything like that, it's a transformer. Yeah, that's about it really. Once I've got it back up in the cabinet and everything's okay, I'll give you a demonstration hopefully, and we'll take it from there. Yeah, bye bye.